In this session, we are going to discuss the third passive elements called inductor. In our previous session, we have discussed about the resistor and the capacitor, which is also the passive elements. This is the inductor is also the passive elements. Is represented by the windings of a conductor here. Inductor is a two-terminal element consisting of winding of n turns capable of storing energy in the form of magnetic field. Now, if you read this sentence, it says that inductor is the winding of n turns. Now, the element here is a conductor. If you're taking one piece of conductor and then making a round or a winding, then it becomes the inductor. Now, in case of the inductor, it is storing the energy in the form of magnetic field. Whereas for the capacitor, it is storing the energy or charge in the form of electric field. Now, this is the difference between the inductor and the capacitor. Now, similar to the capacitor, it also have capacitance, right? Now, for the inductor, it has the inductance. Now, it is the ability of a device or ability of an inductor to store energy. And now it is measured in Henry. Now, unit of the inductor is Henry. The magnetic field in the inductor induces the voltage called the induced voltage. Now, that voltage we can use to drive the current in the circuit. Now, looking at this sentence, it says that inductor is also storing the magnetic field, energy in the form of magnetic field, and that magnetic field is producing the induced voltage called the inductor voltage. Now, the relationship between the current and the voltage in the inductor is given by V is equal to L times di by dt. Now, it's similar to the Ohm's law. Here, in case of the Ohm's law, if it is in the resistor, it's given by V is equal to current times resistance, right? Now, here is given by V times L, which is the symbol of the inductor, times the change in current. Why we are using the di by dt means since we are applying these elements in the AC circuit. Okay, remember that the capacitor and inductor are applicable with the AC circuit. Now, that current and voltage are never constant in case of the AC circuit. That's why there will be the change in the current with respect to time. That's why we're using di by dt. Now, here is the characteristics of the inductor. Now, if we connect the inductor to the electric circuit, then in the beginning it will act as an open circuit, which means that inductor is acting as a high resistance for the current flow. And then if you keep on applying the voltage, supply voltage in that circuit, which means at some time that inductor becomes fully charged. During that time, that inductor is acting as a short circuit. So remember that there are two stages of an inductor. When the inductor is not fully charged, or in the beginning of the supply of the voltage in the circuit, inductor act as a open circuit, or inductor has a high resistance. But if you keep on applying the voltage or any source, any driving force, then after some time when the inductor is fully charged, it acts as a short circuit. Now, these are the two behavior that we have with the inductor. In the beginning, it acts as a open circuit, and after some time when the inductor is fully charged, it acts as a short circuit. Now, depending upon that two behavior, here is the circuit. Okay, I have not specified whether it's AC or the DC, but just simply think that we are applying the source. Now, inductor is connected in parallel with the bulb here, and then it has a switch. And then the question says, what happens to the light bulb when the switch is closed. Now initially the inductor is also connected in parallel with the bulb, and then here we have a source. Okay, remember I'm not specifying this one is AC or DC source. I'm just saying the voltage source. What happens to the light bulb when the switch is closed? Now when we close the switch, remember that in the beginning of the supply of the voltage, this inductor will act as a open circuit or the high resistance, which means our current driving from this source will flow through this bulb, so bulb will glow. Then after some time, if we keep on applying the voltage source in this circuit, the inductors will get charged, and then after when it is fully charged, then it acts as a short circuit, which means in a short circuit we assume that the resistance in that conductor is zero, whereas we consider there are some resistance in this bulb. Therefore all the current will flow through this inductor, which means this bulb will act as a open circuit. So remember that when we close the switch for the some time, this bulb glows, and then when you keep on applying the voltage, it acts as a short circuit. That means this bulb is dimming the its brightness, and then after some time it fizzles out, or it stops glowing. And then again, what happens to the light bulb when the switch is then open? And then there are two stages again. Now we for the second stage we are opening the switch. When you open the switch, we are disconnected with this source, but remember that this bulb is still connected with this inductor. And then remember we have this inductor is fully charged, so we have voltage V is equal to L Gi by dt. So this inductor will act as a source, and then it will drive the current in this bulb through this bulb, and then this bulb will glow. Then after some time, when the stored energy is exhausted in this inductor, then bulb stops glowing. So this is how it behaves. I hope you got the point. Okay, let me explain once again. So we have the voltage source connected in the circuit, which the bulb and the inductor are connected in parallel. In the beginning, when you close the switch, the current will flow through the bulb. The reason is this inductor acts as a open circuit. Now current will flow through this bulb until and unless this inductor is fully charged. Then after some time, when this inductor is fully charged, then this one will act as an open circuit. Reason is it has a high resistance compared with this inductor. Because in case of the inductor, when it's fully charged, it acts as a short circuit. So our current from the source will drive through this inductor, and then it completes the circuit without going through this bulb. Then in the second step, when we open the switch, remember that we have connected the bulb in parallel with the inductor. So this inductor acts as a source. So this inductor will drive the current through the bulb, and then it completes the circuit. When the current passes through the bulb glows for some time until and unless the charge stored in inductor finishes. So when the charge stored in inductor finishes, then this bulb fizzles out, or it doesn't glow. So that's the working of this circuit with when the inductor is connected in parallel with the bulb. So we can also think that how the circuit will behave if the inductor is connected in series with the bulb, and then this voltage source. And then we can also think how that circuit will behave if we connect the capacitor in parallel with the bulb through this voltage source. So we can have so many combinations, and then we can interpret how it works. I hope you got the point.